presentation about conductivity, durability, and reducing weight in the composite using graphene nanotubes. My name is Roberto De Simone. I'm the technical sales manager for thermoset composites and PU in Oxial. And with me, there is Vladimir Kravchenko, is a product developer for our for thermoset resin. He will be maybe later with us during the Q&A session. You are able to text your question in the bottom right side of the screen, so you can type, and maybe in the last 5-6 minutes we will be able to reply. Let's start immediately. I already shared my screen. So just to give you the general agenda of this webinar, first of all, we are just introduce what is graphene nanotubes, all our product portfolio. Later on, we are talking about the main benefit you can get out with the usage of tubal in the host material, like electrical conductivity properties and mechanical reinforcement properties. At the end of the presentation, we just highlighted a bit what means for us using tubal for sustainability, our sustainable policy and our sustainable path in our company, and some additional information about Oxial and our company itself. Let me remind you briefly what is a graphene nanotube. Graphene nanotubes is just one sheet of graphene rolled up in a cylinder form, basically. So it's just one atom of thickness because it's just one sheet of graphene. The length of the tubes is in the range of 5 to 10 microns, while the inner diameter is more or less 1.6 nanometer plus minus 0.4. So it's the nano size of the tubes is just the inner diameter more than the length. Obviously, most of the company are a bit concerned how to use the nanomaterial itself, how to disperse nanomaterial in the host, in the resin or in the host material, generally speaking. And in this case, Oxial R&D developed some specific concentrate based on tubal, which is our brand name of the graphene nanotubes, in a different carrier, which could be more compatible with the final material where we are going to disperse tubal in. And we developed this tubal matrix series, 200 and 300, but we speak about more later on in the presentation, that where the appearance is more or less like black flakes or pasty, and the tubal is predispersed in this kind of concentrate. The content is in between or 5% or 10%. As a sideline, we also develop some water dispersion, like it's just a black liquid with some surfactant agents to keep the dispersion stable. As I highlighted before, we can use the graphene nanotubes just to bring some important properties to the material. On one side, we are talking about electrical conductivity. With nanotubes, we are able to achieve some permanent antistatic or conductive properties, even keeping the mechanical properties when is possible, even to enhance these mechanical properties. In fact, on the right side of the slide, you can see that we are working a lot to using nanotubes to improve, I would say dramatically, but a very good improvement of some mechanical properties in the composite materials, in the composite final part, like flexural strength, flexural modulus, interlaminar shear, fracture toughness, and so on. Just to give you some tips about the electrical conductivity properties. As I mentioned before, we developed this tubal matrix series 200 and 300, where an high dosage of tubal is predispersed in a different kind of carrier, which could be compatible with the target system when we are going to disperse in tubal, like thermoset resin, like epoxy, polyester, PU, acrylic, vinyl ester. We are able, using tubal, to achieve a permanent and stable electrical conductivity, in this case, electrical volume conductivity in the range of 10 power 3, 10 power 9 ohm per centimeter. even as I highlighted before, keeping when is possible to enhance mechanical properties but preserve the color. So it's possible to achieve some different color because of the extremely low loading level of tubal inside. This is just a very brief table to compare the very standard electrical conductivity agent with the tubal benefit. We can say the antistatic liquid agent, the carbon black, which is very common, very traditional, I would say, and tubal as nanotubes. As you can see, the first important things to highlight is just the very, if we are going to make a comparison between the working dosage, you can see that for carbon black, for example, we are talking about a range between 4 and 12% weight percent, compared with tubal, where the usage of tubal in the range of 0.05, 0.1 weight percent can bring a very full range of resistivity with no negative impact on mechanical performances, and very acceptable on the rheology and the viscosity. You can achieve some color when using carbon black. For example, everything is black because the loading level is really high. You can avoid completely the dust formation during the process, during the industrial process, because we are dealing with the plastic, with the flakes, where nanotubes are totally embedded in the matrix. So you can just we can just highlight that there are several sideline benefits beside the main value proposition we are going to highlight, like electrical conductivity and mechanical properties. Like before, we are just is it possible with different kind of formula adjustment or formula optimization inside to get out with very different color from the light one to the dark one. Obviously, it depends on the final conductivity target. If we are talking about antistatic range, obviously the loading level of tubal is lower, so light color is achievable easily. While with the high level of tubal, to get a very strong conductivity properties in the system, so it's quite difficult to achieve light color, but dark color is even possible. Just to give you some example of how to use tubal in the standard application for the standard also technology for composite. The first one is just the filament winding. Filament winding made with glass fiber basically, and is usually used for to manufacture tanks for transportation and storage of hazardous materials or pipes for mining application. We are talking about this kind of target resin system like vinyl ester, polyester, or epoxy resin system. In this case, you can use two different tubal matrix 204 for vinyl ester, polyester, or tubal matrix 301, but with only 0.8% of tubal matrix 204, which means because it's a 10% concentrate, only 0.05% of tubal, you can achieve a volume resistivity less than 10 power 6 ohm centimeter. And this level of resistivity is permanent and stable. So the benefit is really high compared with the other standard material. Another kind of application is pultrusion, and in the composite area, or in this case, we are talking about the GFRP gratings or cable trays for the ATEX zone. In this case, we are talking about mainly vinyl ester polyester resin, so we can highlight tubal matrix 204, and with only 0.2% of tubal matrix 204, which means, as I said before, 0.02% of tubal, the active material, you are going to replace easily 6% weight percent of conductive carbon black, keeping obviously the possibility to have a different color, because, for example, gratis could be used in a different path inside a plant, a nuclear plant, for example, just to distinguish the different kind of area inside the plant. And obviously, so a range of color is a sensitive topic in this case. You have no influence on mechanical properties, even when it's possible. Another application, the third one, is just the SMC composite. You can achieve a very antistatic SMC for usage in a different electronic equipment like electronic box or stuff like that. Even in this case, 6 to 8% of carbon black could be easily replaced by 0.2% of tubal matrix, keeping more or less the same benefit. So what we can get out from this usage of tubal in case of electrical conductivity, the main benefit is important to highlight the permanent and stable antistatic properties. So properties is stable and permanent during the usage, the life cycle of the system, without any hot spot inside, a wide range of color, and obviously you can also keep some original flame retardancy because tubal cannot affect the flame retardant agent inside. The last application I would like to highlight is just the usage of tubal in the spray, gel coat or mold coat for different kind of application like static sensitive equipment, some different electrical boxes, industrial fans, and also even the children's lights to reduce the antistatic effect. In this case, we are able to replace 5 to 8% of conductive carbon black just with 0.2% of tubal matrix 204. Even in this case, we are talking about vinyl ester raising. So, as I highlighted before, it's really a sensitive topic for different kind of electronic industry, or for pipe and tanks, or for different kind of industrial requirement when surface or volume resistivity is needed, to use tubal to reduce the impact on the viscosity, to achieve some different color, to keep mechanical properties with a very stable range of resistance. Now we can switch a bit on the mechanical reinforcement we can get out with usage of tubal. This kind of approach is currently under development, but we can show you some relevant data we can get out, we achieved so far. Basically, one of the important mechanisms for the composite area is just how to reduce the interlaminar propagation of the crack, the fracture, the crack propagation in the fiber reinforced composite. On the left side of the slide, you can see the propagation of the crack inside a neat composite without tubal. On the right side, you can see that tubal can build inside the matrix, the resin system, a 3D network where there is a crash of the propagation. So there is a sort of energy absorbing of the propagation. So in the nano composite where tubal is dispersed. So the path where the propagation is, the propagation path of the fractures of the crack is just reduced and controlled and extinguished by the usage of tubal, because it's a very arduous path, so it's going to expire easily. A couple of words about the current achievement we had with the usage of tubal for mechanical reinforcement. The first one is just the type 4 cylinder with the inside liner of polymer. Using tubal, and tubal obviously is introduced and dispersed directly in the epoxy resin system. We use it in this case a tubal matrix compatible with the epoxy system. And this kind of development was done to achieve this type 4 polymer cylinder for the automotive compressed gas and for hydrogen pressure vessel. The main benefit that we are able to reduce 14% of the weight. So we are just moved from 3.3 kg to 2.85, and they will be easily able to overcome some specific standard for this kind of application listed in the slide. The second one is just how to use graphene nanotubes for thermoset carbon fiber composite bike frame and bike wheel. Also in this case, using a system compatible with the epoxy system, we are talking about mainly in this case epoxy system, we were able to achieve a very weight reduction of the frame, and also increase the hammer impact is a specific test for bike frame 14%, and even the flexural modulus. So just some the later slide is just provides some intermediate result we obtained so far in our Oxial R&D center, which are going to validate day by day. which is our approach, current approach for the reinforcement using tubal. Basically, we are using two different approaches. The first one is just to design the 2K epoxy system. Basically, our new, the first result we got so far are mainly related to the 2K epoxy system, and it was validated in our lab. The potential application, well, the epoxy system is used commonly in the filament winding for pressure vessels, pipe tanks, as I highlighted before, pultrusion as a rebar profile and also beam, hand layup, and pre-preg for different kind of application. Currently, we are using two different testing methods. The first one, we developed a tubal matrix solution, like tubal matrix 216 beta, is a master batch 1% dosage inside. And the second one may be worthy in this case is just to disperse tubal in a tailor-made solution on a very target resin. What does it mean? It means that we are going to receive from the end user, from the manufacturer, their own resin system, where we are going to disperse tubal in a concentration of 1% in weight, providing them a very compatible system because it's based on their own resin system. Some short information about all the properties we were able to enhance so far with the usage of tubal in the reinforced epoxy carbon fiber composite. I would like to highlight basically what is the last line, the bottom line, the fracture toughness G1, with the standard is ASTM D2344. We are able to enhance up to 52%, even something like the tensile properties and interlaminar shear as well, so sharp index. So you can find easily that using tubal, you can obviously have a direct impact and direct benefit on your mechanical properties. It's important to evaluate with the customer, while electrical conductivity is just one property, for the mechanical reinforcement is important from the customer point of view to have a precise target where we are going to because they want to highlight. That's why it is important to get out the information, which kind of properties the target customer wants to highlight in the target technology as well, because all these parameters are important and needs to take into account for the development itself. Roughly, a graph to put in comparison fracture toughness with the delamination length. You can see on the red spot the control system we used and the net reason, and on the blue spot the increased fracture toughness, the system where when tubal, the active material, is dispersed in the contact with 0.08%. Nice pictures, I would say, because it's really important to see from the microscopy point of view how is possible, which kind of bridge tubal can create between the different fibers. So on the left side, you can see the neat composite, and on the other side, what tubal is able to develop inside the system. So it's really, really evident that the fracture toughness can be increased and dramatically. I would have words about our sustainable approach. Obviously, we talked about so far with the main product values, so the main benefit you can get out using tubal, and for above all, if you are focused our attention on the mechanical properties, we are able with tubal to get a weight reduction and reinforce of the total of the overall composite part. We are able to improve some specific properties like flexural strength, interlaminar shear, and improving creep resistant fracture toughness. We are able also to enhance and to prolong in a certain way the life cycle of the part. Obviously, from the business point of view, this is a big impact because it's quite easily to understand which is the benefit from the business point of view. But on the other side, if we're going to improve mechanical properties, to improve the life cycle, and in a certain way to reduce the energy used to produce, to reduce the content of the carbon inside, because with a low loading level and increasing the operational lifetime and so on, obviously there is a direct impact on the carbon footprint, which can impact tremendously, I would say, the CO2 release and the carbon footprint inside. So the usage of tubal can enhance, on the other side, the sustainable approach of the company, because using tubal, you can increase some properties, you can make longer life cycle of the properties of the final part. So it's really relevant that from the sustainable point of view, this is absolutely a positive. Couple of words about our company. Oxial was founded in 2009. Currently, we have more or less 450 people as employees and more than 1,500 customers all over the world, I would say. We are the first company who developed the industrial production system for single-wall carbon nanotubes, or graphene nanotubes, just for the one sheet of graphene. And just to give you a couple of words about our capacity, only in 2020, 98% of global production of graphene nanotube was made by tubal. We currently have 3 different tubal research centers. The first one is in Novosibirsk, when our main manufacturing plant is located. The second one was opened in 2019 in Shanghai, and the third one was opened last November here in Luxembourg, where our European headquarters is located. Now we are able to support 100% all the development with different kind of resin system like thermoset, but even thermoplastic elastomer in our lab. And on top of that, it's important to highlight that our Tubal Research Center here in Luxembourg is able to disperse, for some company who doesn't have the right equipment, some lab scale concentrate to give them the chance to test Tubal, because there is some processing guidelines to follow, as sometimes people or sometimes some company doesn't get the really equipment. So it's important to say that if you need, or your company needs to receive some specific tips or some specific help to disperse tubal, we are able to do currently in Europe, in Luxembourg. A general overview of how our organization is located. We have different kind, 3 R&D centers, as I say, 2 production facility, one in Novosibirsk, and the second one is building here in Luxembourg to reach something like 350 tons per year of tubal as a production capability. Our supply chain is a via distributor. I would say that 95% of our customers are via distributor. We have a different distributor located all over the world. We are REACH registered. We are allowed to commercialize up to 100 tons in Europe, and we are also EPA, Environmental Protection Agency, registered for US, and we are able to sell up to 10 tons of tubal in US as well. So let me stop. I hope to have been clear, and now I can stop the share. And we can just jump in the Q&A session. So I invited Vladimir to join us. And maybe there are some different questions, so I can highlight.
Yes, thank you, Roberto. Hello, everyone. It's time to conduct a Q&A session. So first of all, again, thank you everyone for the participation. Yes, very quick note that this presentation and all the mentioned documents which were mentioned by Roberto, yes, it's a selection guide, the product selection guide, and the processing recommendation processing guide for thermosets for Turbomatrix 200, 300 series. They are available in the special section of this JEC tool. Yes, thank you for the JEC organizer as well. So Q&A session, yes. I answered some of the question already in the chat. Also, it's almost, let's say, half of the day, but we kindly invite you to our booth in JEC Online. Also, you can leave your a message request, a business card, or also video calls, they are available. So there are some technical issues, as I understand from the organization, but more or less it's possible to be in contact. Also, if you have any questions, you can write to webinar.dogaxel.com. I write it many times in the chat to discuss your precise case. So now let's go for question and answer, which we received in the chat. So one of the question was, could it be integrated in the composites to project them from the lightning strike events? Yes, yes, we had in the past a few project and commercial stories in this application as well, but it will depend on many things. Yes, is it a coating? Is it a part of the layer, or is it in the composites? So I think that in the thermoset area, one of our record was 002 all multiplied centimeter, but it was a really thin coating. It was a very big dosage. Generally, if we speak about standard epoxy resins, we are working in the range like 10 power 3 to 10 power 9 all multiplied centimeter or ohm per square. Other applications, of course, they are also possible, like MEI shooting, electrical heating resistance coatings, and they require, of course, they need lower conductivity. So again, it's better to discuss all the parameters, yes, and limitations of the technologies and etc. So are you able to sell the mentioned dispersion in large commercial quantities? So Roberto, feel free to answer.
Absolutely, yes. Our process is on industrial scale. We are able to fulfill all the requirements. We are, as I mentioned before, we are more than 1,500 regular customers in our portfolio who serve it via distributor or as a direct sale. It depends on basically, as I highlighted before, it's possible to get in touch with our distributor all over the world. We have a different distributor in Europe and in Asia, in the US as well. So it's absolutely yes.
Great, thank you. Also, the question was about the solutions for epoxy systems, because it's one of the most common system on the market for many applications, especially with the high performance requirements. So we have different approaches, yes, as I mentioned. For example, as a reference, yes, for electrical conductivity, we have Turbomatrix 301, which is a concentrate with 10% of nanotubes inside the system. And the carrier is a surf content, but you shouldn't be, let's say, afraid of the carrier, because the dosage of the concentrate will be less than 1%. In many cases, it's less than 0.5% weight percent to the total resin system without fiber. If we speak about mechanical reinforcement, it's a epoxy master batch, which is included 1% of tubule inside. So to check the epoxy equivalent weight, again, feel free to write to our webinar dogaxel.com. We can send you the TDS. Also, for European partners, we have other options to discuss. Yes, we have a tubule technical center in Luxembourg. We have a lot of equipment to handle the thermoset systems, and in some specific cases, some specific projects, we are ready to supply tailor-made approach. Yes, if it is feasible, of course. So it means that you can get your resin and prepare a master batch with the different dosages. So, but of course, it's let's say, it's some kind of sensitive topic, yes, because we need to know the carrier and all the technical parameters and limitations. Also, thank you, Roberta. Yes.
Yeah, I just sent on the public chat the three main documents: the processing guidelines, the selection guide, and this presentation. So you are able to download and check again. And if you have any question, you can come to our virtual booth, or you can drop us an email or a message just to get in touch easily.
Yeah. Also, very, very good question from what about non-destructive testing and control of geometric parameters, which we use or our partner use to, let's say, to clarify the quality of the composite part here. So currently we have some kind of limitation in our center. We produce composite using hand lab technology with some vacuum assisting. Yes, sometimes we also play a bit with some infusion methods. Yes, and we just use a basic screening. Yes, so it means that basic testing of nanotubes influence on it. Yes, like tensile performance, flexural, of course, they are destructive. So we don't use any non-destructive methods currently in the laboratory. But we know that from the past that some of university or some, let's say, well advanced our partners, they have their own way how to evaluate the cracks inside the pipes. But I think it's one of the topic on the cutting edge. Yes, so there are a lot of models and equipment, but they have also many limitations. So again, for the question, I think it's more precisely we can discuss it on our booth or after this
Event.
presentation. Yes, also any areas where not applicable to ball. It's a good question. I mean, let's speak about composites. As Roberto mentioned, for example, for filament winding, pultrusion, hand layup, yes, a pre-preg, the nanotubes usage, the resin is feasible and possible, and we demonstrated the effects for conductivity and mechanical properties which you can expect. But for example, if you look on the vacuum infusion or resin transfer molding, currently we do not promote or propose any products there because nanotubes have some kind of limitations of the viscosity and also the filtration during the big production, big scale. So I think at the current development stage, this is one of the example. And of course, it's more related, it's a universal additives, but of course, it's a technical tool with pluses and minuses. And we are trying to be more let's say, to define which applications have all been validated in technical and commercial point of view. Yes. So I think we answered the question.
No, there is
also,
a new one.
For example.
Yeah, the new one. We use a Tubal 204 in gel coat. If the gel coat surface not sanded, we found that the conductivity is less. How to improve it without sanding the gel coat surface?
Great. I think that it's let's say it can be not only the surface. Yes, it can be related also, for example, in many gel coat applications. One of the ingredients in the gel coat, it's a fumed silica. Yes, like a lot of commercially available grade on the market, like aerosol 200 or others. Yes, and they have a very small particle size, like 12, 20 nanometers, and the typical dosage is roughly like 2%. And when you use the fumed silica in the gel coat system, they can isolate matrix particles or nanotubes particles, which can lead to the high resistance value. Yes, insufficient. So we also have some technical recommendation how to solve it. I think it's more technical questions. Again, the author of the questions, we kindly invite you to write or to go to our booth. We can show you how to solve this issue. Or also, of course, we can discuss the sanding the surface, but I think it's not maybe the crucial moment here. The formulation can play higher, let's say, impact on this. And of course, Roberto, a lot of our participants say personal thank you to you, yes, for the great and impressive presentation.
Thank you. Thank you to all of you to join our presentation. And we are in the booth till 6 o'clock, 6 p.m. So feel free to reach out
till the end
to us. Yeah, absolutely. Thank you so much again.
Yeah, thank you. If we skip for some reasons, I think no, your questions again, we kindly invite you to the booth or to write. You can leave your business card or message or write to our webinar.axel.com. Thank you very much.
Bye.
Yeah.